So my name is Daniel Ruben. Welcome to the webinar for battery insulation testing, together with my colleague 𝗀𝗂𝗋𝗄.
Yes, welcome everybody from me as well. I'm the head of product management at Hioki Europe, and I will take care of the Q&A session during this webinar. So if you have any questions for the Q&A, then please put them in the Q&A box that you can find at the bottom of your screen. And at the end of the webinar, we will look into those questions.
Yeah. So as Rai already said, the webinar is structured that it's being recorded, and afterwards we will also share with you the link which we will upload on YouTube. During the session, which takes roughly 30 to 45 minutes, all of the participants are being muted. And at the end of the session, we have the possibility to answer the questions you have submitted to us through the Q&A function. Please see that the chat function is disabled, so everything which pops up into your mind, please add into the Q&A function, which you can already start from the very beginning. So let's look into the webinar, what we want to show to you. First of all, we want to give you a basic understanding of why and how insulation testing is being done. We want to show you the benefits of our latest product, the 𝗵𝗵𝗃, which is a battery insulation tester, and how it can be beneficial for manufacturers for battery cells. And also what I want to show to you is we have already an existing model for for insulation testing, and we want to show you why 𝗵𝗵𝗃 is different to the current existing portfolio of 𝗵𝗵𝗃. During this webinar, what we want to make you understand is the main 4 functions why this specifically is interesting for the battery industry. We have a so-called breakdown detection function where we will give you more details for the development in the charging capability, especially for the battery industry, is a nice feature we can show you. Then we have 2-wire contact check function compared to a formerly 4-wire contact check function, and also an improved noise resistivity, which is especially interesting for the production facilities. The webinar will give you first the knowledge of what an insulation tester is doing compared to a withstanding tester. We will then have a closer look to the application of the battery industry. The 4 main features as shown before on the slide, we will show you in detail, and then the comparison between our new product 𝗵𝗵𝗃 versus the existing insulation resistance tester 𝗫𝗃𝗃. And at the end, we will have the Q&A session for all the questions you still have. As a start, the basic knowledge, what the HiPod tester is doing compared to an insulation resistance tester. So as you can see here on the screen, we have the insulation resistance test versus the withstand test, also so-called HiPod test, which is basically a safety test. So as you can see here on the application already, we have here a cell, while the safety test is being done with the pack or the module. And typically, this test is being done with a high potential in order to identify if there is already any deterioration happening with the insulation. So the insulation resistance value is the most interesting parameter you want to get out of that. While when you do a dielectric withstand test, you want to understand if you have any current leaks. Or alternatively, also from a safety point of view, you also want to understand at which applied level of voltage there will be a potential breakdown of the device. So these are the 2 main different applications, cell versus final pack or module. And now we look into the circuitry of the devices, because this is the main differentiation of the test method. So as you can see here, the withstand voltage test is taking care of leak current measurement, while the insulation resistance test is taking care of the resistance measurement. So what's happening here inside the device? So we have a stable DC voltage, which is being applied to the battery or the DUT. And then we have the current sensing. And from the knowledge of our device, we know that we have a very stable DC voltage being applied, and the current we are detecting, we can then calculate the resistance value. And this gives the manufacturer or the tester an indication of the resistance value or the insulation value of the device being under test. While with the withstand voltage test, we have either a DC voltage being applied or an AC voltage being applied to the DOT. We simply only look at the current. So the current resolution is the main interest, because what you want to take care of here is any safety concerns, like users being could get some leakage current. So any hazard for the user, this is what you want to exclude when doing a high potential test. There is also a differentiation within our portfolio. So we have 3 main products. One especially for the battery industry. It's also a DC withstanding test, 𝗀𝗶𝗂𝗁𝗃. Then we have a combination AC and DC test, and we have a pure, more commercial side where you have then the 3174 only as AC. All of those 3 also come with an insulation resistance test capability, but please be aware that the insulation resistance values you are getting here, they are much higher than we have here with the insulation resistance tester, which are specifically for testing the low resistance values here, the high resistance values here. What you can see, we have BT5525 and we have ST5520 as insulation resistance tester, and SM7110 or 20, depending on the applied voltage, and also one portable device. And the reason how to choose is basically shown here, depending on the level of voltage being applied. So we have the latest product, BT5525, which is applying 500 volt, specifically looking at the battery industry, so on cell level. While the ST5520, more general purpose insulation tester, is capable up to 1 kilovolt. Also, we have 𝗀𝗶𝗹𝗁𝗃, which have a higher test voltage, but the differentiation between those 2 is basically the resistance value. While with 10 gigaohm, you would be absolutely fine when testing battery cells. The component testing requires a much higher resistance value, and therefore the display range of resistance value is much higher. As a third step, we would, or third category, we have withstanding testers, also in combination with insulation resistance tester. So not any longer looking on cell level, but looking at pack and module. Here, it's the safety test to understand at which level you might have a breakdown. This is especially interesting for class type testing. Type class testing, or you have the end of line testing where you need to apply a much higher voltage. Now let's go a little bit more into the application, especially looking at the process of manufacturing battery cells, in which the BT5525 is relevant for. Here is a typical process of how a battery is being produced. So first we have here electrode sheets, for which we also have RM2610 as a tester to give you already an understanding at the very early stage if your electrode sheets are having a good quality. So basically for high capacity of battery cells, interesting. The next step is when the electrode sheets and separator sheets are being produced, they are getting winded and stacked. Afterwards, once they are winded, you have the tap welding process, for which we recommend RM3545 as a milliometer to understand whether you have too high resistance of your battery cells. Once the case is being closed, you have the electrolyte filling process. And typically here, you would start with the insulation resistance test. So before the electrolyte filling and after the electrolyte filling. And this is being done with an insulation resistance tester, First, before the electrolyte filling, when you test between anode and cathode, so between here the two poles, and after the electrolyte filling, the resistance becomes very low inside. So you will then look at the resistance value being derived or measured from electrode against enclosure. Here in italic, we have it as an end-of-line testing. So insulation resistance also becomes interesting here, but it depends on if the cells are already connected to each other. So if you have already a bus bar or tap wells, so either you have the testing from cells to enclosure, then an insulation resistance tester is still being used, or when it's already completely assembled and soldered together, you will have the entire system voltage, and that is already the time when you have the safety test for module pack. So the testing would be happening between enclosure and the battery pole of the entire pack or module itself. And now let's look a little bit closer how we see it in the market when manufacturers are doing this test and how they are doing their test. And at the moment, there is no standard available. So every manufacturer is a little bit doing their testing differently. That means they might do it at different times, and they also do it at different voltage level to be applied. To our knowledge, it's approximately 200 volts, which are being applied. And then it depends, especially when you are in early stage of the development or in the production process, you might have more often the testing in order to understand if you have potential quality issues later on. And of course, why would you want to do that testing? As I said, the quality is an important level, but you want to understand as early as possible if there are any issues with the battery cell, so that you can at the end increase your productivity and reduce any production time and cost for failing battery cells at the end. There is one big challenge, especially for the battery industry, which does make it necessary to understand if the battery cell is in a good shape or not. And this is so-called contamination. So what you can see here, the problem is when you apply a DC voltage and you have some parts left in the battery cell, especially metal parts, you have so-called breakdowns. And this is something you cannot avoid, because during the process of producing the anode, cathode, and separator, you have a cutting process. And that cutting process, it doesn't matter if it's being done with laser cutting or mechanical cutting, will lead to certain particles being left. And those metal particles, especially from the separator, you have copper, aluminum foil, these small particles, when applying a certain test voltage, they will have a reaction. And that reaction, as we call it here, breakdown or partial discharge, will leave some damage to the separator sheet. So with a common insulation resistance tester, you will simply increase the test voltage. And here you see a drop in the test voltage. This is when a reaction or breakdown is happening, partial discharge. And while this breakdown is happening, it kind of burns some damage into the separator, and it typically burns off. And then the constant, the increase of voltage is happening again. So a typical insulation resistance tester would see it as a pass, even though a partial discharge has happened. And what happens if you have several of those partial discharge? Well, it makes your battery deteriorate faster. You might also suffer from a self-discharge, and in a very bad scenario, you might actually have a battery cell which can be hazardous because it can catch fire and even explode. So what Hioki came up with is a device specifically tailored for the battery industry. And we have four main features, which were shown at the beginning. We want to tell you about more in detail now. So it's a breakdown detection function. We have increased charging and discharging capability, two-wire contact check function, and noise resistivity. And in this chapter, we want to show you why it is especially interesting also for the production side. The first part is the breakdown detection technology. We call it breakdown detection technology because what we currently see in the market is a partial discharge detection technology, but only looking at the voltage side. So from the BT5525 on, we have a different testing procedure as we have seen in the market yet, which is not only monitoring the voltage, but also the current. We have two circuitry now inside this device. The two circuitries are looking first for short time discharge pulses at a very, very fast sampling speed. So 5 megasamples per second, giving you a very clear picture and more data points, while we also have a detection circuitry for slow transient pulses. So what happens in the process of testing with an insulation resistance tester? So first, we have the charge period. The charge current of 50 milliamps is getting injected into the battery cell. And due to the limitation of that charge current, in this part, it's only possible to monitor voltage. While in the regular period, once it's charged, you also have the possibility to capture voltage and current. We have three colored areas in here. These two areas, they are for detecting the voltage. This area is for detecting the current. And this is something the user of the device can set as a threshold by themselves. So once you are here having a drop in voltage, or you have a drop in voltage in here, or a spike in current, and you are outside of the set threshold, this is seen as a count, as a BDD. So you have a breakdown you are detecting in either of those two periods. And this is an additional feature which gives you a much better interpretation of your battery cell, because you don't have no longer a pass based on resistance value only, but you also have the capability of counting how many of such breakdowns or partial discharges you have seen in your battery cell. So this gives you now an advantage of creating your battery cells, because if your cell has passed based on the resistance value, you might don't want to let it pass if you have too many of those partial discharges. And the positive thing here is the BDD count you can then also use for grading. So you might have a range of, let's say, 3-4 BDDs, and those 3 or 4 BDDs are still seen as a cell level grade A. In reality, there are no cells which don't have any BDDs, because there is always certain contamination. So as a battery manufacturer, most likely you will be interested in how many of such partial discharges you have, because this gives you then an understanding about the contamination inside the battery cell. And also, it gives you then the possibility of using graded cells to sell maybe for high capacity applications like racing cars, or a cell grade C you can still use for a vapor, so e-cigarettes. So anything which gives you more interpretation will be beneficial for you to understand how to use the battery cells for which kind of application. What also has changed now, we do not only have the BDD count for the numerical value, we also offer a PC software, which gives you a good interpretation analysis of these BDDs happening. So what you can see here on the screen, we have the voltage, we have the current, and of course the resistance value as a third parameter. And with these waveform observations, you have the possibility to better understand what was happening inside the battery cell. So this can improve your processes of the battery production, battery cell production much better. Besides these values like numerical values or waveform data, you can make use of the PC application software also to set all the values, especially to set all the parameters and settings. So this is especially interesting for system integrators. And of course, you can use these data later on for analysis, how to improve your process of the production. But the most tricky part is how to determine whether there was a BDD happening. So how this is being done. We have seen you have 3 areas you can set as a threshold, and once you have outliers, these will then be counted as a BDD. But the most tricky part is how to set correctly these thresholds. So one point of the main features was that we have a higher noise resistivity. And this is very, very important when you want to set thresholds as close as possible. When you are in a production environment, you have much noise also around, coming from conveyor belts, so everything where you have frequencies and frequency inverters in robotics, pick and place. And therefore, the higher noise resistivity is very, very important to make the BDD count as close as possible. Compared to ST5520, the more general purpose insulation resistance tester, we no longer have only a banana plug, but we have a BNC cable, which is more shielded, making it more immune against any noise from outside. And now becomes tricky part, especially for the system integration of the ST5520. It is important to set the threshold as close as possible, and therefore it is necessary to have several tested samples. So roughly saying 100 samples as an example will give you a good understanding whether the threshold is set too low. That means everything here where you have the little spikes is already seen as a BDD count, while only this one should be seen as a BDD count. The other extreme would be the threshold is set too high. That means none of those are counted as a BDD. So it's in an ideal world, you have a very, very close setting of threshold, which will only look at this outlier. So it really depends on individual customer sites to set the thresholds correctly to have a proper BDD count. Another very, very important point is how to make the production or the cycle time of the battery testing as efficient as possible. And therefore, we have an increased charging current. Before, we only had 25/25 of the 50 milliamps charging current. And now this makes it much, much faster. And the problem is that you have the higher capacity of battery cells compared to typical component testing, for instance, and therefore the charging current is a very, very important feature of the BT5525. Also, the discharging time, in order to have a very quick cycle, charging, discharging is important. And therefore, with this increased capability, you have a faster cycling time. There might be even the situation that you want to increase the cycling time even more. And now it becomes interesting, especially for system integrators, how they can make their production offer to the battery manufacturers more interesting. And this is by having a reduced testing time. So how this can be done, also in combination with our sample program, we can give you many, many data points thanks to the fast sampling, which will give you good interpretation how a battery cell typically is reacting when you apply a test voltage. So what you see here when applying the test voltage, after 10 seconds, you might have 80 mega ohm, and after 60 seconds, 100 mega ohm. in a cell you are grading as a pass, you want to achieve 300 megaohm. So expecting that that after 10 seconds you only have 80 megaohm will lead to 100 megaohm. You could already judge that this cell most likely will be a fail. While after 10 seconds you have already 100 megaohm, you could expect that the resistance value is increasing, and that would be around 300 megaohm. So with the many samples you have tested, giving you the statistical interpretation that after 10 seconds, this and this value would be reached, and assuming that after 60 seconds, seen from historical data, 300 megaohm would be reached. This is a way for you to reduce the test time. Of course, this requires several samples to be tested, but this is still a way for you to improve your cycle time. Another very, very important feature, especially for the production side, is that we have decreased from 4-wire contact check function to 2-wire contact check function. As you can see here, there are 3 scenarios where a contact check function is important. So one scenario could be that the test lead somewhere is broken, or your test lead is not probing correctly. So when you have a very the conveyor is not bringing the cell to this position where you have a proper contact, or the robot is not placing down correctly, you will get a contact fail message. Or another case could be that the tips of your probe are already degraded. So these would be situations that there is a contact fail happening, getting back to your PLC or anything what drives the process of the testing. And with this information, you have a more reliable production. One big advantage is for system integrators, especially, that no longer 4 wires need to be wired. So this is already eliminating any wiring efforts. And secondly, especially when you have very, very small places to probe on, the 2 pins are much easier to set the contact compared to 4 points. So therefore, the 2-wire contact check function is a very advanced way of easily giving you a feedback, is the contact being done correctly or not? And how this is being done? Our device is using capacitance measurement, and you can then set thresholds based on these specifications. So as you can see here, we have from 100 picofarad up to 200 nanofarad the possibility to set the thresholds. And if you have values outside of this range, you will receive a contact fail error message either on the device or transmitted as a command to the PLC. So therefore, it's very good to, or very efficient when you set those thresholds to see if you have any contact errors or not. As a last point, we want to give you an understanding when a general purpose insulation resistance tester is being used, while BT5525 as a battery insulation resistance tester is superior to for your application. So from the overview, you can see here the test voltage of 1000 volt with ST5520 is double the time, but for battery cells, you would not need anything higher than 500 volt to our knowledge, and therefore the 500 volt is completely sufficient. The difference in the application is that the capacity, parasitic capacitance of batteries requires a much higher charging current, and therefore the 50 milliamps will give you a faster charging speed. The difference also here is that the 4-wire method has been now reduced to the 2-wire method. So again, beneficial for system integrators. And what is different, that especially because of the production process of a battery cell, that you have contamination inside. The breakdown detection technology gives you a much better understanding and interpretation if your battery has passed, how it has passed, and therefore a good way for you to create your battery cells. Also, what is possible now, we have of the very fast sampling of the circuitries, the chance to do a waveform observation. So this gives you a better way to interpret how your battery cell is reacting and the reasons why it was happening. So as a summary, what brings BT5525 to the market? The breakdown detection technology, which is completely new in the market, not only monitoring voltage, but current and voltage, so much more sensitive to detect any contamination inside the battery cell and if you have partial discharges. Also, the fast charging and discharging speed is very, very important for the battery production, makes it then very convenient for production cycling times to be reduced. The two-wire contact check function makes the device very reliable when being in a production environment, especially the noise resistivity. Don't let any noise come into your detection so that you do have any wrong BDDs as a count. Now we are already at the end of the presentation and happy to start now the questions and answering.
Yes, at this moment we still don't have any questions in the Q&A session. So if you have any pending questions, please put them in the Q&A box so we can take care of them. But so far it seems that your explanation has been clear, but we will wait a few minutes to see if there are any questions coming up.
In the meantime, while waiting, if there is no question so far, but later on, you can always reach out to us via this mail, hioki@hioki.eu. Also, we have here in the presentation, which we will share with you after the recording has finished, a link on which you can find in your specific country where you are located, our partners, which can also support you on the questions you have.
Okay. In the meantime, we have some questions coming in.
Yep.
One of them is from Sven de Koster. He is asking why we show that the test range for the insulation test is 500 volt, but why do we suggest 200 volt? Well, that's basically the experience that we have from our customers, that typically they will do a test around 200 volts. So that's from experience that we have gained from our customers. And then there's another question, anonymous attendee, so I'm not able to give his name, but is this battery tester only useful for lithium-ion batteries, or can it be used for alternative battery technologies? Would you like to answer that one, or shall I answer that one?
Please do so, Roy.
Well, because it is a kind of a safety and insulation test, it doesn't matter what kind of technology of the battery you are using. So it is applicable for different types of batteries as well. So if you're looking at solid state batteries, might be a little bit different, but if you are working with a liquid, then it's not an issue. You can use this battery tester for all those applications.
Yeah, I think it also depends a little bit on what you want to achieve with the battery. So especially looking at lithium-ion batteries and the production process here, due to the metal parts being inside, and also from the application point of view, it makes sense to find out about any partial discharges happening in here. While, let's say, commercial batteries, lead acid, they are not so much prone to deterioration like lithium-ion batteries, for instance. So it really depends on the application background and where the battery cells will be used for.
Okay, then we have another question. Do you suggest AC or DC for the BDD test?
For the battery industry, especially, it's a DC test we recommend.
Yes, and we use a DC signal to do the analysis of the BDD.
Yeah.
And then another question from Emre. Are there any measuring accessories for the BT5525 tester for multiple channel measurement?
I would not say so, because typically what you will have is a test fixture, which then keeps the two test leads inside, and then typically in the production facility, especially, you would have a conveyor or something which brings the battery to the next position, where you simply go down and probe.
Yeah. Okay. There is a possibility also to use the switch, but we don't recommend it because it will create some interference. It might create some interference also in this test. So normally what Daniel described, a cell will go through the process and will be positioned at a point where you do the test like this with the instrument directly connected.
Mm-hmm.
And let me see if there are any further questions coming in. Yeah. How much faster would the charging and discharging time be with the new BT5525?
So you can see here we have a charging current with the ST5520 of 1.8 milliamps, while now we have 50 milliamps with the BT5525, basically 25 times higher.
Yeah, and for the discharge, it's also important because many of the traditional testers are using just resistance to discharge the cell. The disadvantage of that one is the voltage is going lower, then the current will drop, and it will take a lot of time to discharge the cell fully. But with a constant current, you can shorten that discharge time quite a bit.
Yeah, up to 40 milliamps.
Yeah. And then another questions. You showed measurement times of 10 to 60 seconds. Is this the recommendation duration for each measurement, or can it be reduced once parameters are set?
Basically, this is more kind of an indication what we also see in the market, that the test voltage is being applied for around 60 seconds. And this is when typically the test is being finished. And based on the statistical data the device is collecting, you have the capability to already say or assume that after 10 seconds, we see this resistance value, and we assume that after 60 seconds, it would lead to this. So yeah, this would be a rough suggestion, but of course, it really depends on your environment as well, and therefore also on the battery cells, something where you would need to do several samples to be tested to clearly state, okay, I'm so much % certain that after 10 seconds, I can already see if it's a fail or a pass, and also something where let's say the guarantee or the reliability is a little bit down to your requirements.
Yeah. What I would like to recommend, if you look at this pass in this graph, you see that the 10 seconds is basically the start of the linear part of the increase of the resistance measurement. So it would not be wise to use a point which is earlier than this 10 seconds, but in other situations, in other cells, it might be that you start already this linear part at an earlier stage, but that's depending on the cell that you are testing to decide how long you want to measure to make sure that you have a good indication of the insulation resistance of your cell. Okay, And then we have another question from Carlo. What kind of setup do you recommend for multiple channel tests? Well, that's basically.
I think this is a little bit the same question as we had in the beginning.
Yeah.
So the multiple channel, we are not suggesting to use a multiplexer unit, but to have a fixed probing station and then contacting the battery cells, which are pushed on a conveyor belt, for instance, through the probing setting.
Yeah. Or if you have a matrix of cells that you want to test, we also have different solutions, but that are flying probe testers. But yeah, that is also a possibility to use the flying probe tester.
Or the system integrator could come up with an XYZ portal, then moving the pins where it should be.
Yeah. Yeah. And another question coming in. Since we can't test the same cell multiple times, how can we get curves like this to predict the internal resistance at 60 seconds, for example? Yeah, that's really when you start doing this kind of measurements, you really have to take a lot of samples in your pre-process and then get the statistical information of the cells. And then with that statistical information, you can decide, okay, after 10 seconds, this is the minimum value that we need, or if this threshold is below that value, then it might be a fail. If the value is higher, it can be a pass. So it's really something that needs to be decided on the particular cell and the particular situation.
Yeah, and especially first when it's being installed on site, nothing we can do in advance.
Yeah, and then there's another question from Thomas Eager. Are there an overview from the different devices to the functions, like the BT3562? Well, the BT3562 is a different device. So it's not an insulation tester, but it's really measuring the internal resistance and the open voltage of the cell. So it's a different application. But yeah, there is an overview of all the different measurement instruments that we have for the battery industry. And there's also a landing page we will share with you, where you can find all kind of information about the Hioki battery testing products.
Yeah, but in any case, it would make sense maybe to reach out to us so that we can go a little bit closer into your application to understand what is your purpose of the measurement, and then we can decide which product makes most sense for you. Because the BT3560 series is typically already a test not for the battery cell anymore, but in most cases, it's already the pack or the module you are testing. And you simply want to have a maybe inspection or end of line test to understand the internal resistance value or the voltage level of your battery cell, pack or module.
Okay.
There's one more question that I think we jumped over, is just to reconfirm, BT5525 can be used during the production process as well as after pack assembly? Was the one question.
Yes, well, yeah, please go ahead, Daniel. Yeah.
I will show again here the beginning to have a little bit better overview. So what we see here is a test voltage where you also want to have a smaller voltage, because you have first here the test between anode and cathode, and then when it's filled, you have a low resistance value, and you will increase the test voltage over time. So when you have the pack or the module, we would already suggest going to a high-pot safety test, because what you are interested in here is the insulation resistance of the battery cell inside, while with the pack, you are looking at the installation of everything being assembled already. So it's a different approach, because again, one slide back, when you have the cell, rather the resistance value is being of interest, while you have already seen on cell level the resistance value. You want to ensure that there are no leakage currents floating anymore, and therefore we would not suggest any longer the BT5525, but in this case SD5680.
Yeah. So ideally, the BT5525 is used on cell level. It can be used in pack level, but that's more for troubleshooting, basically. So if you have any issues with the pack and you want to determine which of the cells might be the problem, then you can disconnect this cell from the bus bar and do the individual check on the cell itself. But normally on a pack level, you will test with higher voltages, like for instance, 2 kV or 4 kV.
Yeah. And for those customers and viewers being interested in withstanding test, but also installation resisting test after cell production, so especially for pack module, shortly we will also have a webinar for SD5680 talking explicitly about the next steps after the cell production.
Yes. Okay. I think that concludes the Q&A sessions. I don't see any questions coming in anymore, but we will wait just a few seconds to see if there's anything changing.
So if not, thank you very much again for the participation. After this session, we will send you the link to the YouTube recording. You will also receive the presentation as PDF files, and everything what was not mentioned inside or unclear. Please feel free to reach out to us or any of our partners. And thank you very much for your attendance. Have a nice day.
Thank you. Bye-bye.